Now the topic is single phase full wave control rectifier, right? So there are two kinds of configurations we are having: one center tapped configuration and two bridge type configuration, right? See, whatever the video lectures I am going to prepare on single phase full wave control rectifier, whatever the waveforms I am going to analyze, those are just related, those are just similar to both center tapped configuration and bridge type configuration, right? So before going to explain the single phase full wave control rectifier operation with R load, that means before going to analyze the waveforms of this particular R load of single phase full wave control rectifier with R load, let me give you a topic, analysis on what is center tapped configuration and how the bridge configuration looks like, right? This is what the center tapped configuration we are having, and here this is nothing but V not, sorry, yeah, this is Vs, and the value of Vs is nothing but what? Vm sine omega t, that is single phase supply we are going to give Vm sine omega t, and this is we are having three terms A and B. See, this is here center tapped in the sense what the load is going to be connected at the midpoint of the particular transformer, secondary transformer, and we are having two thyristors T1 and T2, right? So during positive half cycle T1 is on. The reason is what? V is positive with A is positive with respect to B, as A is positive, anode is positive to this, and here B is negative, anode is negative here, so it will be open circuited and it will be short circuited. So that is what I have been represented here, and the current used to flow in this particular fashion, that I have represented here. If you apply KVL, V naught equal to positive Vs, right? Next, that means whatever the supply voltage you are going to get, that supply voltage is going to be appear over this. See, this positive, so A, and you are going to get A here, and you are going to get AN here. So VAN is nothing but what? Vs, right? So V naught equal to positive Vs. Similarly, in the negative half cycle, as the polarities are going to be interchanged, right? Negative is connected to the what I meant to say, cathode terminal, so it will be turned off, and positive is connected to the thyristor T2, that is anode terminal, it will be turned on. So thereby, if I am going to apply the KVL over here, so V naught equal to negative Vs you are going to get. That means whatever the supply voltage you are going to get, that will be appearing across this particular load, right? This is what. Similarly, right, similarly, coming over this, similarly in bridge type configuration also we are having four thyristors. In center type transformers we are having center type configuration, we are having two thyristors, but in bridge type we are having four thyristors, T1, T2, T3, T4. So this is one kind of representation we can consider, right? So what is happening during positive half cycle? If you clearly observe it, during positive half cycle A is positive and B is negative, right? So A is positive and B is negative. So positive is connected to the thyristor T1 anode, so it will be short circuited, and negative is connected to the cathode of this thyristor T2, it is short circuited. And if you consider one thing, A is positive, right? Positive is connected to the cathode of T4, so it will be open circuited, and negative is connected to the anode of T3, it will be open circuited. So what is the current, what is the equivalent circuit you are going to get here? So A is positive, so T1 and T2 are going to be on, so the current used to flow like this. The current used to flow like this. It is from T1 and R, and from T2 and from T2 and to the negative and to the supply. That is what. So in this positive half cycle, T1, T2 are on, and T3, T4 are off. So whatever the supply voltage A, see, this positive is connected towards this, right, load, right? So positive. So positive is nothing but A, negative is nothing but B. So VAB is nothing but what? The supply. VAB is nothing but what? The supply. So the supply voltage is going to be get over here, that is across V naught equal to VAB equal to Vs. Similar case in the negative half cycle, T1 and T2 are in off position. See, in the negative half cycle, in the sense what? Now A is negative and B is positive, represented here. So when A is negative, so this negative is connected to this T4, so T4 is going to be on, and this negative is connected to the anode, T1 is going to be off. So, and B is positive, so B is positive to negative, so T2 is going to be off, and positive to cathode, T2 is going to be off, positive to anode, T3 is going to be on. So how the current used to flow here? So current used to flow from positive. So like in this particular fashion the current used to flow. So this B is going to be represented over here. So B is positive, right? So positive is going to be across T3, and then to the load terminal. So B is connecting over here and E is connecting over here. So what is the output voltage? VBA is nothing but what? V naught equal to VBA. VBA is nothing but what? VAB, that is nothing but Vs, negative Vs. Understood or negative? Yes. So this is what you are having. So this is the entire representation, ma. This is the entire representation. You have to remember these kind of things. What is center type configuration and bridge type configuration, right? So with the help of this procedure, right? With the help of this procedure, whatever the duration I have explained till now, with the help of the particular concept only, I am going to draw the particular waveforms, right? I am going to draw the waveforms of each and every load, even it is either it is R load, RL load, discontinuous, continuous, whatever the things you are going to consider, you have to remember these two things, that is what is happening in positive half cycle and what is happening in negative half cycle. These are the only two things you have to remember, but the waveform will remain same in both center tap and bridge type configurations. Yeah, so the waveform remains same in both center tap and bridge type configuration, but the only thing here is in center tap configuration, only one thyristor used to get conduct in positive half cycle, but and another thyristor used to conduct in negative half cycle. But here a pair of thyristors T1 and T2 will be conducted in positive half cycle, T3 and T4 are going to be conducted in negative half cycle. So if it is an R load, right, if it is an R load, if I am going to draw the expression, I mean waveforms of this particular R load, what is going to be happen? See, this is for both center tapped and bridge configuration. Again I am saying you, in center tapped transformer, only T1 is on in positive half cycle, but in case of bridge configuration, both T1 and T2, two thyristors are going to be, SCRs are going to be in on position, right? Remaining will be off, right? So what is going to be happen in the positive half cycle? It is VAB, right? VAB is going to be appearing like this, right? See here, this is VAB, this is VBA, negative off. Understood over, right? I have given alpha over here from alpha to pi, and similarly as in the resistive circuit, both voltage and currents will be in phase like this. And again at pi plus alpha, what is going to be happen? Negative half cycle, T1 is off. See, here is T1, right? And now here T2 is going to be turned on for center tap transformer, and then it is 0. Similarly, it is 0 up to here, and the current is going to be happening like this. I hope you understand what I am saying. See, if it is center tap transformer, here T1 is turned on and here T2 is turned on, right? If it is center tap, and if it is what I mean to say, bridge type configuration, then right, then what is going to be happen? Here T1, T2 are turned on, here T3, T4 are turned on. See, simple representation, simple representation. You have to remember the conditions. Whatever the explanation I am going to provide you, you try to remember each and everything. Understood? Or so in the same manner, you can draw what I mean to say. You can draw the same. I mean, voltage across the thyristor also, right? Alpha. See, try to mention these angles here. I am not mentioning here. So VT. So voltage across the thyristor is short circuit, so 0, and here also short circuit, it is 0. Before, who is conducting here? Here T1 is conducting. So here T1 is conducting in the sense T2 is in off position. So there is no means of having any kind of conduction. So T1 used to conduct in this particular fashion, right? So here T2 has been turned on. T2 has been turned on. So short circuit. So but before, what is the value you are having? VBA value you are having. This is the condition you are having. I hope you understand what I am saying, right? What I am saying, from alpha to pi, from pi plus alpha to 2 pi, and 2 pi plus alpha to 3 pi, right? So please try to catch my voice so that you won't get any kind of what I mean to say, confusion, right? So this is what R load. So let me derive the equations for average output voltage and RMS voltage with for R load, right?